Now, in previous examples of future values, there was an amount of money that sat in an account for a certain length of time and was allowed to grow. But for most accounts, we usually contribute to the account at regular intervals or time periods. These types of accounts are known as ordinary annuity accounts. The future value for an ordinary annuity account grows faster than a regular compounding interest account because there are consistent deposits that are made. So the future value for an ordinary annuity is FV, future value. That's going to be equal to D. Now D can be thought of as a deposit or a deduction. Times that to E. E is our effective rate. We learned that a couple of sessions ago. And divide that by R over N. Now E is taken right from the future value for compound interest. That's the rate. That's 1 plus R over N to the N times T power. Now, since this is a rate is a percentage is per 100, we have to subtract out 1. So then this problem says, your new employer offers a 401k pension account. Your plan allows $200 to be deducted from your paycheck every month and deposited into the 401k plan that earns 6.9% annual interest compounded monthly. A then says, what is the future value of this account after 40 years? And B says how much of the value in the account would be earned from interest. So again, I like to list the variables as we read through here. So it says your plan allows $200 to be deducted. So that's D. That's our $200. That's being deposited into your 401k account. That happens every month. The rate, that's 6.9%. So we have a rate of 6.9%. And it is compounded monthly, so N is 12. And then A says, what is the future value for this account after 40 years? So then the time is 40 years. So the idea here is that your employer every month takes out $200 out of your check, puts it into your 401k account. That's for retirement. That account earns 6.9% annual interest and it's compounded monthly. How much money will you have 40 years later, maybe when you're ready to retire? So the first thing we should always do is find the value of E. Most of the calculations that we're going to need are going to be found in E anyways. So E is equal to 1 plus the rate. That's 0.069. Over the number of pay periods, that's 12. That's then 12 times 40 years. That's the length of it. And then we'll minus 1. Now, since I need this R over N for the future value, I'm going to determine this separately. So we'll do 0.069 and divide that by 12. So here I have 1.00575. 12 times 40, that's 480 minus 1. So now in my calculator, I'm just going to type this all in just like this. So 1.00575. Raise that to the 480 power. Hit enter. And then I could simply just subtract, just go right to the operator here, subtract 1. And that gives us 14.6754. 4205. So then for the future value, that's the deposit, that's $200, times the effective rate, 14.6754 0.6754 4205. And then we divide the whole thing by the interest rate divided by the pay periods. And of course, that's right here. And that's what this is right here. 0.00575. So now this whole thing, I could just type in my calculator just like that. 200 times the rate, 14.6754 4205. And then divide it 0.00575. So the future value for your $200 deposit for 40 years, by the time you're ready to retire, you will have $510,450. And of course, we're going to round to the nearest penny and 16 cents. That's why 401k plans are a very good idea. They're very good plans. So that's a lot of money to retire with. Now, B says how much of the value in the account would be earned from interest. So now you are depositing money, $200, every month for 40 years. So you were putting in $200, or your employer was putting in $200 every month. That's 12 months a year for 40 years. $200 times 12 times 40. That's $96,000 that you or your employer actually contributed. The rest of it is interest. So what was the interest? Well, we'll simply take the $510,000, 450.16, subtract the $9,600. So 510,450.16 minus the $96,000. Hit enter. And you made $414,450.16 in interest alone.